Hey guys, today we start off on our new unit on kinetic theory, states of matter, and basically the behavior of particles. And we open up with a picture here of a little freezing fog, and that'll come into play later. One of the extra credit questions at the end of this VOD. But basically we need to start thinking. We just got through our atoms and our subatomic particles, and now we're going to get into a little more in depth with how those particles behave, and basically look at the theory of how scientists believe them to be moving. Now here's a look at all the states of matter, and there's actually one more which we'll talk about in the next podcast, which is the Bose-Einstein condensate, which you may or may not have ever heard of. But what the main ones we're going to talk about in this podcast are your common ones you're familiar with, and we'll go through phase changes with them. So we're going to take a look at solid, liquids, and gases, and then we're going to give a special attention to plasma and the Bose-Einstein condensate when we go through the next podcast. So what we're looking at here, there's several things you have to keep in mind. We're looking at the difference between solids, liquids, and gases, and we're looking at molecule movement, volume and shape, and the kinetic energy of those particles. And so molecule movement is how the molecules move, and that does deal directly with kinetic energy too, and we'll talk about that. So solids, they're close together. They vibrate in a fixed position. Because their kinetic energy is low, the bonds that hold them together are not able to be broken, so they're strongly attracted to one another. That means they're going to have definite shape and volume, and so all that means is if I have a chunk of rock, it has a definite shape. Its shape's not going anywhere. If I put it in a glass container and dump it out, that shape's not going anywhere, and neither is the volume. The liquids, their particles are also close together, but they're allowed to move a little bit more. They have a little more kinetic energy, so they're able to move a little bit more than, say, the solid. Even though they are so close together, you look at a jar of liquid, a jar of Kool-Aid, and you don't see empty spots sitting around in there. Now, they have definite volume, but indefinite shape. So what that means is they'll fit into the container you pour them in. So if I have a large, wide glass or a tall, skinny glass, I can pour it in there, and the shape of the liquid may change, but that volume's not going to change. And then the gases, the molecule movement's very random. They're bouncing all around. They're hitting off the container that they're in. They're hitting into each other. And that kinetic energy is transferring between those atoms. And so what happens here is they don't stick together when they hit each other because they have high kinetic energy, and they're able to break those bonds and move away from one another when they do collide. So we have that kinetic energy is allowing them to move away at faster rates. And what this basically comes down to is there's a greater amount of heat in the gases than there is the solids. And again, heat and temperature are different things. Okay? Gas has indefinite volume and indefinite shape, which basically means I can put a certain amount of gas in a container. I can, just like in the previous slide, I can pull that plunger up and I can increase the volume. And there's no definite volume for that gas. It'll expand to whatever container it's in. If I compress it, I can compress it down into a smaller volume, and that gas is going to fit in whatever container it's in, and also it's going to fit with its shape. So looking at these three, those are the three things we need to keep in mind: are the molecule movement, the volume and shape, and the kinetic energy. All right, so let's take a look at how these phases change and how these different states change from solid to liquid, from liquid to gas, from gas to liquid, from liquid to solid, and even from gas to solid or solid to gas. And so we have here, we have some arrows drawn up. Yeah, they're not quite arrows yet. I need to add some little points on there. But basically, as we move from solid to gas, remember, kinetic energy is going to change as we move from solid to gas. It will go up. Okay, so our kinetic energy, or Ke, is going up as we move from solid to gas. Now, what that means is that can pull apart the bonds that hold together these states. So if we have solids, solids are going to be very structured, close together. Remember, definite shape, definite volume, sitting nice and together in the container. The liquids, remember, they're going to take the shape of the container. They're going to be a little bit more spaced out. They have a little bit more kinetic energy, but they do still are able to move in the container, and they can take the shape of the container. The gases, they're filling up that container. They're moving around. They're bouncing off the insides, and they're spaced out. So what we have here, looking at these different particles, again, this is due to the kinetic energy of those particles. So as we take heat and we add it, I'm going to go over this line. We take the heat, and we add it to these different states. We change their state, and that's called a state change. And you should know these. These are pretty similar, pretty familiar, I should say, to what you've done in the past. I'm sure these should be something that's at least comfortable with you. So as we add heat, the solid, again, gains kinetic energy, and so those bonds begin to loosen, and solid to liquid, that stage is melting. Okay, so that state change is melting. If we add more heat, more kinetic energy to the liquid, then we go to gas, and that would be boiling or vaporization. So we have a change from the liquid state to the gas. We boil that liquid, and the kinetic energy breaks those bonds and changes into gas. The gas, if we were to cool it down, we go from, let's say we're taking away heat, okay, so we have less heat going back. Then to cool it down, we would be condensing or condensate. If we're going from liquid to solid, we're putting it even further. We're taking away more kinetic energy, then it would be freezing. Now, we can jump the liquid state if we have rapid heating or rapid cooling, and when we're going from solid to gas, we have something called sublimation, and that'll be a point of discussion on Blackboard here later. And then if we're going to go from a gas to a solid, so we have some rapid cooling, that is called deposition. And again, that's going to be a subject later on Blackboard. So looking at these state changes, you can see that as we add heat, we break those bonds, we add kinetic energy. As we take away heat, those bonds become harder to break, we take away energy, and those particles don't move as rapidly. Alright, so let's take a look at a graph of these phase changes. We're looking at melting and freezing and vaporization, boiling, condensation. And what we have here, we have right here our freezing point and also our melting point, and that we're looking at, let's say we're looking at water here, so we're looking at H2O. And what we have here, here's our temperature on our y-axis, and right here we have, in Celsius, we have 0 degrees Celsius, which would be our freezing point, but it also would be our melting point. Up here, when our liquid is turning into gas, we have our boiling point, but we also have our condensation point. So we have a point where our liquid and our gas is not quite changed into the gas state. It's still a mixture. So what happens is we're adding heat. You can see that down here. Heat is added to the solid. So again, solid water, so ice. It's added to the ice, and we have an increase in heat and temperature right here. Okay, so an addition in heat, the overall energy raises the average energy. Now, you'll see here we have, for quite some time, it's not instantaneous. We don't have a transition from solid to liquid instantly. We have it all needs to be changed over, because remember, temperature again is the average. So we're looking at all the particles have to get to a point where they are moving above the rate of 0 degrees. And so what we have here is this solid-liquid mixture, and at that point it's still 0 degrees. So you can have one ice cube in a cup that was originally frozen, and it's thawing, and that ice is melting. If you still have that piece of ice in there, that water should still be at 0 degrees. Now, when that last piece of ice is melted, then we're going to see the temperature start to rise. As that heat increases, we see a pretty rapid increase in temperature. And again, we hit a point where we have liquid and gas, and it's together, and we get the boiling of water. And at that boiling point, it's also a condensation point. So you're going to have water, you're going to have gas at the same time. When you're boiling water for macaroni, for your cheesy noodles or whatever you're eating, your macaroni and cheese, it doesn't just evaporate into gas. You have a mixture of gas and water. So that's the point where we level off here. And again, we have that average of 100 degrees. The temperatures are 100 degrees. Remember, temperature is the average measurement of the kinetic energy. And then once all the liquid has boiled off, then it becomes a gas only. Okay, so there's these points and these phase changes where we have a combination of both phases until we get kind of over that point of all the particles are above that temperature, and now we're moving up along that phase change graph. Okay, so your VOD assignment for tonight, which you need to bring into class for our next class period, is to copy the state change diagram from slide 7. So the state change diagram, that is your 3 containers of the solid, liquid, gas, and all the movements going on there between those, and what those movements are called. You need to copy that down and show that you've looked at that. And then it says draw and describe underneath what the particles are doing in each state. So you need to draw out the particles like I did in that slide, and you need to describe there underneath the diagram, so maybe at the bottom of the page, what each one of the particles are doing in terms of kinetic energy. Now, if you want some extra credit, we just had the test, and so we can use a little extra credit. It says, send me a journal entry on Blackboard. It should be as to how freezing fog, like the white substance from the opening of the slide, is created. And for that matter, what is fog? Is it a liquid? Is it a gas? What is it? So answer that on Blackboard. You can send that to me through the journal. You can go to Tools on the sidebar there, go to Journal, and there's a link that says Private Journal, I believe, and you can send me that for some extra credit. All right, we'll see you in class.